Hello and welcome to the DLOS workshop. I've been asked to make a small video on workshop practice, particularly machine shop practice. So we'll just concentrate on my machine bench. Now I think I'm going to struggle here a bit because people who know about machine shop practice probably don't need to know the elementary stuff, and people who don't know about the elementary stuff are probably not that interested in machine shop practice anyway. But we'll see how we go. We'll start off by looking at my lathe, which is here on the right, and then we will not worry about the drilling machine. I think most people know about that. And then we will spend some time looking at the milling machine. Well, here's the lathe. Essentially a lathe is for working with round things, and you can make them shorter or you can make them smaller in diameter. So I'll turn the lathe on, and making something shorter, just touch the tool against the brass there and then take some off. So there we are, that's shorter. Of course I don't have to go the whole way, I could just go in like that. And we can have a little shoulder. Or we can make it smaller in diameter. And again, of course, I'm not measuring anything here, just taking bits off to show you. So there you are, you can imagine I'm making 7mm models. The world's your oyster, and the sky's the limit. Now if you want a hole in the middle, that's quite easy too. You use a centre drill, which is just a very stiff drill. And in we go. And we have a nice hole. If you want a bigger hole, just put in a bigger drill. And essentially, that's what a lathe does. Well, here we are on the milling machine. A milling machine essentially works with things that are flat, and it makes surfaces with flat. Of course, you can only take material off, so we'll have a go at taking some off. Now, the first thing we do is bring the tool down to the job so that it's zeroed, as it were. Having found the zero, we can then take the tool out of the way. We put on some cut. I'll turn on the milling machine and we will then feed. Now I'm using a piece of aluminium because it's nice and soft and I can sort of get on with it. But you can see it's cutting away there nicely. We've just put on a bit more cut and we'll come back again. And there we have the beginnings of a step in a little piece of aluminium. Now I'm actually using a milling cutter which is known as a slot drill, and that's because it can make slots. So just to demonstrate that, we'll have a go here. Again, I'll touch the surface, but this time of course I've got to put the cut on and plunge into the job. So we'll just do that and then I'll put a little feed and make a little slot. A bit more feed, and a bit more slot. Now there are all sorts of other things you can do, you can imagine, but in principle that's what a milling machine does. I did ask on the forum what people would like to see in my little video. I did get lots of suggestions for quite specialised things to make, which probably wouldn't be of interest to everybody. It would take quite some time. But the most popular suggestion was, how do you hold things while you're machining them? And it's a very good question because that's usually the most difficult bit. Twiddling the handles by the right amount and in the right order is relatively simple. Sometimes holding on to the job is the most challenging bit. If we start with the lathe, up at the headstock end, you can just use the drill chuck to hold the job, just as you hold the drill in the tailstock. And I managed for many years with just these two. Now there are better ways of holding the job, and of course it's easy. This chuck will hold round things and it will hold hexagonal things, but things can get more complicated. So let's look at a better device for holding stuff in the headstock. Here's a collet, which is 3 parts: the collet holder, the collet itself, and the nose. Now, I'm sure many people are familiar with a collet. The modern collet will actually close down and take a range of sizes. This is actually a 6 to 7 millimeter, so it will hold a piece of 1/4 inch brass. It's quite clever how it works, because there are 2 tapers. One goes in the holder and the other one goes in the nose. And when you put them together, the nose closes down on the holder and the collet gets smaller and holds the job. So that's a collet, and that's quite nifty. Many people will be familiar with the self-centering 3-jaw chuck. Self-centering in that all the jaws come in together isn't necessarily that self-centered, nothing like as good as the drill chuck. Nevertheless, it's really useful for holding round stuff. And of course, because there are 3 jaws, it quite conveniently will hold hexagon material as well. Now, there you go. Now that's fine for small things. If you want to hold something a bit bigger, you can actually turn the jaws round and use them the other way around. Now here's an example of holding a ring, and that's a classic use of a self-centering 3-jaw chuck. Now that's round stuff, and you can hold hexagon stuff as well. Job comes a bit more tricky when you've got something like a rectangular bar. In this case, you might use a 4-jaw independent jaw chuck, where each of the jaws has to be adjusted separately. I'll just put that in there. So there we have a piece of rectangular bar. Now this can be quite a game, getting the bar in the centre. But that's how you have to do it if you haven't got a better way of holding it. And again, the jaws can be reversed so you can hold bigger stuff. Now, when it comes to holding square things, the traditional way of doing it is to put the square in the 4-jaw chuck and then fiddle with each of the jaws until the square is in the middle, and it takes some doing. One of the answers is to have a self-centering 4-jaw chuck, and these are not common. You might say to me, "Ah, David, you're just being flash now," but I like my toys. I don't use it very often, but when I do, it's the bee's knees for holding square stuff or octagonal stuff. Not that I've ever done that, but there we are. Chucks and collets are relatively new innovations when it comes to the lathe. Original lathes were indeed called centre lathes because the job was turned between 2 centres. This one, the live centre, because it rotated, and this one, the dead centre, because it didn't. Now this is an ideal job for turning down Slater's axles, either just the middle portion to make them a more realistic diameter, or turn the whole thing down so it'll fit Finney axle boxes. I haven't got a Slater's axle, you just have to imagine this piece of hexagonal brass is it. It's fastened inside a dog, and the dog has got a leg on it, and it goes into the catch plate. We put this in there, and we run that in the back there, and now we can machine away at least this portion of the axle. Now, in fact, this axle bar's got a 6BA hole in the end, the same as Slater's axle, so we just turn it round, put the driving dog on the other end, put it back between the centres, and because it is between centres, it will be in exactly the same place, and then we can finish up machining the other end. If it all goes according to plan, when you join in the middle, you cannot see the join. So that's turning between centres. Now sometimes, with the best will in the world, with all the collets and chucks and turning between centres, there's still things you can't grip. And a very useful technique is to make a split collet, which essentially is just a tube with a slit down the side. This goes inside the chuck, and when you close the chuck down, it closes the slot slightly and grips whatever it is that you're trying to get hold of. Now, very often you can make a collet and just drill it out to the right size and then cut the slit afterwards. But sometimes, and this collet has already been made, but sometimes it's necessary to make the collet up because You just haven't got to drill the right size, and to do that you use a boring bar, which essentially is just a lathe tool which cuts on the inside of a hole like that. And you get it so that it's just a nice fit on the job. In this case this was for a boss of a fan, but having made the collet, you then cut the slit. When you put it in the chuck, the boss of the fan just fit it in, close the chuck, and it just closes up that gap, and that's enough to get a good grip on it. But let's look at a few more collets. Well, here's a practical example of using a split collet. This is a buffer from a ready-to-run locomotive, and I want to shorten it and put a screw thread on the end. Now, it's a difficult sort of thing to get hold of. It's fine if you want to do something at that end, but to get hold of this end, split collet goes on over the shank like that. When it's in the chuck, squeeze down, and now I can machine away the end, turn it down, put my die on to cut the thread. Very difficult to do without a split collet. Now, in fact, this one which I'm showing is slightly too small because the chuck wouldn't be able to reach over it. So the real one I actually used was this one. Now, because the collet's got quite large now, a single split wasn't adequate. So there are 3 slits. One of them goes right the way through, and the other 2 go nearly through, and that makes the whole thing much more flexible, so when it's in the chuck it can be squeezed down and grab the shank of the buffer. So I've got a number of these collets, and they're all the same sort of idea. They all do the same thing. I always keep them because I think they'll come in useful for the next job. They never do. You always have to finish up making another one. But who knows, one day. Now, one of the jobs I'm often asked to do is to bore out chimneys. It's quite easy to bore them out, particularly in white metal, if you can get hold of them. So I've got a wooden split collet. It's actually literally split in 2, either side of the chimney. Grab hold of it like this. Now, to get it running true, because all white metal castings are anything but, I use the 4-jaw chuck, and then I can move it around with the 4 jaws until the chimney's running true, and then it's a very simple job just to machine out the inside. That's collets. When you're working on things, you want to grab them on the outside. But the other side of the story is to use mandrels. Here we have a piece called the mandrel, which goes in the lathe, in the chuck usually, or in the collet, and whatever it is you're working on slips over there, and you then retain it with a screw, and then you can machine it. So it's good for sort of spacers and washers. I've got a whole number of these which will fit different sorts of sizes, and again I keep them because they might come in useful, and usually I finish up adapting an old one and just turning it down a little bit. Put spacers on if the thing you're trying to hold is too small or too thin. The specialist one here, I've got a mandrel with a 12BA thread cut on one end and a 10BA on the other, and I use this to make half nuts. That is, nuts which are only half their thickness. Put this in the chuck, put on the nut, do it up, and then you can machine away half, undo it, and you've got a nice little half nut. So that's mandrels of various sorts and sizes. I've talked about turning between centres, chucks and collets, but sometimes it still isn't possible to get hold of the job. So if you can't get hold of the job, the thing to do is to fasten it to something that you can get hold of. Now here I've just made up this example. We have 2 gears, one the final drive gear and the other primary gear before it, and I want to split the 2. Well, I could get hold of it in a special collet or homemade collet there, so that the collet doesn't damage the teeth. But it's better really to make a mandrel with a spigot like this and then literally solder the gear onto it. And having got it there, you can then machine and separate the 2 gears. And while that's done, you'd have a rather rough edge on the boss in between. You can machine off the face. Having done that, you can unsolder it, and then maybe you want to take this gear, solder it on there, and then you can machine that one as well. Now that's all very well if you've got a brass gear, but I once had a job where I had some aluminium gears that needed machining, and then instead of a solder chuck, you have a shellac chuck, which is really what clock makers use. Shellac, you just warm it up, warm up the mandrel, and press it on, and when it cools down, the shellac hardens. You do your machining, and when you're done, just get the whole lot out of the chuck, warm it up, and the job falls away. So that's a solder chuck or a shellac chuck. Of course, that's an example where I've used it in the lathe, but you could indeed solder your job to something for milling. When it comes to holding things on the milling machine, of course, you can use a vise, as I showed you in the introduction, or if that's not possible, you can use dog clamps. Two of them here. You may well be familiar with those with some smoke box doors. Essentially, you can put the clamp in place on the T-slot in the there, and then nip it up. Actually, even finger tight makes a pretty good job, but normally you just get the spanner on it and nip it up a little bit. And there we have a piece of brass bar ready for milling. Now here's a little clamping exercise which is a little bit more advanced. It's actually not for me, it's for a friend of mine who wanted me to mill up some switch rails. Now you can do this with a file, but it's not so easy and it doesn't do such a good job. And you can buy them, but not at the moment. What we see here is the rail, which you've just seen me clamp on, up against a bar which is clamped onto the milling table at the correct angle. And we are going to mill the first piece here. So I'll start up the mill. It might be a bit noisy, so I won't talk over that. The cut's already on, so we will just feed. My thumb is in the picture there just to hold the rail against the bar so that it is held securely. So that's one pass. I won't go through the whole laborious operation because we need to do it 4 times. Right, that's the end of the milling, and so we can remove the job from the table and see what we've got. And it's perhaps a bit difficult to see, but there indeed is the rail reduced and it's slightly tapered. Should have mentioned perhaps that I was using 3mm carbide slot drill there, and clearly I was milling on the side. Job done. All we have to do now is do the head of the rail on the other side. I've talked a little bit about getting hold of the job, and I thought it might just be useful to move on to the milling machine and just look a little bit at how you can get hold of the job and then move it about so that you can mill it. Now, if you want something round, you can do it on the lathe. If you want something flat, you can do it on the milling machine, but sometimes you want a more complicated shape, maybe a hexagon or a square, in which case one might use the dividing head or the index head or the indexing tool, as it's sometimes called. And here we have the chuck mounted on a disc which has a number of holes, and it can be moved round and locked into position. Now this one's actually got 24 holes, so you can get the useful sort of 30, 45, 60, 90 degrees. Gives you a number of faces. And then of course you just twiddle handles in the right order by the right amount and you finish up with what you want. And it's really very useful. Now one of the crafty things about this particular system is that the chuck that you've used in the lathe can also be used in the milling machine, and that's very handy because it means that the job is still at the same setting, so you can then take the chuck, put it back in the lathe and carry on where you left off. The dividing head, or the division plate that I showed you earlier, is great if you want something uniform like 30 degrees and 90 degrees. If you want something with some awkward angles in, the rotary table is the tool for the job. Again, you can use the drill chuck or the lathe chuck and it screws right on. And now we can move the table round by any amount, and one turn of the handle here is actually 10 degrees, but it's calibrated so you can turn it another 3.5 degrees if you want, and you finish up with any angle that you'd like. Very useful tool. And here there's actually a plate on top which has a thread that will hold the chuck, and I'll just take that off and you'll see what I'm talking about. There we are. It's the standard thread lathe chuck. Now this is actually a different rotary table, but I want you to illustrate something. You actually can be raised and lowered at different angles like that, so you can do sophisticated things like fluted safety valve covers, but you don't do that very often. They use it to illustrate that it would normally have a T-slot on, and you can then fix a vise or use the clamps, which is really very handy. But it's not all beer and skittles, because it's quite difficult to get the job in the right place, because obviously with those two slots at right angles, there's a limit to where you can actually put the vise. And in many cases, I find it's easier to just use the lathe chuck, 4-jaw chuck, and move the job around in the chuck by manipulating the 4 jaws. Again, it isn't easy, but it is possible, and that's how I do it. I'd like to make a couple of comments, really based on some of my bad practice. I've got the milling cutter here mounted within the collet, within the holder, which is the right and proper way of doing it. And you'll notice earlier that I actually held the milling cutter in a drill chuck. There's absolutely nothing wrong with this with a very small machine, but I wouldn't dream of doing it in an adult-sized milling machine. You really should hold the milling cutters in a collet. Collet not only holds the cutter more accurately, it holds it with a far better grip, and there's no danger then that the milling cutter will work its way out of the chuck and do a mischief to the job itself and possibly you. So here we are with a milling cutter in the collet. Thing is, I've only got one collet and one set of collets and one collet holder, so I generally hold the job with the collet and I then hold the milling cutters with a drill chuck. The other thing is, you saw me earlier using my thumb to hold the rail up against the bar while I was machining it. Now, in fact, it's probably perfectly okay again on a small machine like this, but I really shouldn't have done that. What I couldn't find was my piece of wood, which is what I normally use, and you can see I've chewed a few bits out of it already. So don't stick your thumb in the milling machine. Again, on a small machine like this, it's probably not too bad. Sticking plaster will sort it out, but it's definitely keep your hands away from a full-size milling machine.